to start, right? Hello. 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 Okay. Just time to start. Right. Cool stuff. And yeah, if you want to, thank you. Right. First of all, go to GitHub and get this repo because all the information is there. This is kind of like a semi self-driven tutorial. So what I mean is that there's a lot of exercise that you are supposed to do it yourself. So you can try it out and kind of, I do believe in learning by doing it yourself. So that's why there won't be a lot of hand-holding. Of course, you can ask questions at any time. But yeah, you have to go to this GitHub. Go to GitHub, go to my account, the name there, and /NL_FastAPI. Yeah, let more people come in and settle down. But anyway, in the meantime, please get this repo and you can use that to work on your things. Yeah, and I just woke up an hour here, so I'm just melting, so don't mind me. Yeah, if I look really, really hot, because I am. Okay, so how many of you have used FastAPI before? Okay, so I think this may be too easy for you because this is meant to be for people who have never used FastAPI before. Of course, we'll be deploying some machine learning model later in the workshop, but we won't focus on the machine learning part. So we assume that you already know all the things machine learning. It's just that you are trying to use FastAPI, so you can kind of have a model, so you can deploy it in a server. So for example, it's you can build it for your team to use it together, or maybe like you have users who need to have API access to the model, so you can do that. So first of all, check if you have Python. In this workshop, I'm using Python 3.12. I know it's a bit old, but it's it's quite stable, and I think most of you will 3.12 will work for you. So that's why we're using that. We will also use other libraries because, again, we will have some machine learning model we're deploying. So it will be quite a simple model from scikit-learn. So we'll mainly use scikit-learn for now. But you may ask, like, oh, if I have a more complex, like AI model that like let's say GPT from I download from Hugging Face or something, like you can also do similar, use similar method to maybe fine-tune your model and then use FastAPI to have an endpoint, so you can use it with the the transformer pipeline for that as well. But to make things simple to start with, we just use scikit-learn today. If you really want to know more about what if I have I'm using transformer, I'm using some like LLM or more sophisticated AI model, then talk to me afterwards and we can look at that together. Right. So also we would at the last part of the tutorial, which is part 3, we will touch on a little bit of Docker. So if you don't have Docker, haven't used it before, I think the easiest way is to get Docker Desktop. So yeah, any of you don't have Docker on your machine? No? So this is good? Okay, cool. Yeah. So in this repo, there's like a requirements.txt, so it will all be there. And if you don't use UV, use UV, use other things, it doesn't really matter. We're not looking into UV today, so it doesn't matter. Right. So So some of you have used Fast API before. You don't need this introduction, but for those of you who haven't used Fast API, so what is Fast API, right? So so if you let's say you want to build a server, and so other endpoint client users will make some request API calls to the server, and then the server will provide some response back. So that's very, very basic. Let's say you have a machine learning model. You want a user to send you a request, give you the all the data that need a prediction. Let's say that give you the parameters, so you need to make a prediction. What you can do is that you can put your machine learning model as a server. So someone can make an API call, then you do some prediction in the background, and then give back the result to the user. So Fast API lets you do that very quickly, because Fast API basically lets you set up an API server very, very quickly. You will see how it works. It just uses a lot of decorator to define the endpoint, and then it also come kind of out of the box. It's already have a very simple way of running a server that you can just set up very easily. So why is it useful for machine learning? Well, I mean, if again, like if you have a model that sometimes you don't want to just ship the model, and then the user need to have knowledge of Python, have knowledge of how to set up all the requirements, and maybe to set up the model and run it locally. Then maybe the easiest way to put a machine learning or AI model in production is to provide a server that you open this API, and the endpoint user, no matter they're using Python or JavaScript or whatever, they can easily get the result from your model. So that's why it's quite useful. Another thing that why Fast APIs is loved by many people is that because it has a very good documentation interface, which allows you to try out the endpoint. So it will be quite useful, especially in a workshop. You can just try if it works and stuff like that. Hello. Okay. Hi. Hi. Okay. So I don't know what happened. But yeah, it will let you to test out the endpoint. So it's quite good. So far, any questions for Fast API? No? Excited? Want to try it out? Yes. Okay, good. So first exercise, of course, we start with very, very basic, which is Hello World. We all know Hello World means you're just doing it for the first time and trying it out. Yay! Of course, if you haven't done it, install, set up your virtual environment, install all the requirements in the requirements.txt, and then you will also install Fast API, and then you can start coding. So I would suggest you go ahead, have a look at the exercise. You can copy this code in your IDE, and then follow the instructions, play around, and change a little bit of things. So this part, I won't hold your hand. I would like you to experiment for it yourself. And if you have any questions or found anything that's weird, let me know, because that's how we learn. And then we'll come back and look at it together. All good? Yay, okay, let's do that. How's everyone doing? Finished exercise 1 already?
Yes.
Yes. Have you tried out any other query to see if it works, or maybe the name stuff? I don't know if it's like, oh, I turned it off, sorry, I'm stupid. Okay. Right. So, everybody good with exercise 1? Do I need to go through it, or? Good. Give me a thumbs up if you're good. Yes. Okay, I see some good thumbs up. Okay, so, well, of course, that's just a starter. We are not just like, saying, checking, oh, just some query, just print it out, it doesn't do anything, right? Just get you familiar with how, FastAPI work and using the interface and, and also try out the doc interface, which you can use it to try out the endpoint. So, okay, let's look at how we can integrate it with a machine learning model. So, as a start, like I said, we'll start with something very simple that, oh my god, my internet's not working. So, anyway, yeah. I think, I haven't touched it for a while and it just logged me out anyway. So, if you look at the scikit-learn model here, you will see that, it's in a notebook. That's probably very similar to what you do normally. I just put some machine learning code in a Jupyter notebook. It works fine. That's what I want my model to perform. That's all good. But again, I want to deploy it to someone who may not be familiar with Python ecosystem. They may not have Jupyter notebook. They just have maybe they're a front-end developer. They develop JavaScript, but they want to use your model. So what we do is how can we put this into our FastAPI amazing server, right? So this is very simple. It's just a scikit-learn. I think it's using a KN model, K-neighbor classifier to try to predict if you give some parameters of a measurement of a penguin. What kind of penguin is that? So that, that's basically some machine learning 101. You may see this database before, data set before that, it's just a cute penguins. So that's very simple, but again, if you know how to do this, you can apply to any model that you want. So, right, so first of all, FastAPI doesn't work that well with Jupyter Notebook, so we probably have to not use Jupyter Notebook and get everything into a Python script. So, so you can basically see, so also get the data. It's if you want to try it yourself, we need the data set. So download the data, and then after that, we have to put everything into min.py because remember, our server, here, this is doing nothing, but now we want it to do something. So we need to add the code from that Jupyter Notebook into this file. So, oh, by the way, so this, after you do exercise 1, I think you already have the feeling of that, so using app.get, you can define an endpoint, and you can also accept some parameters using some typing, which I know some of you have just attended a tutorial about typing, so that would be really useful here now. So, okay, now, before we can do anything, of course, we need to have a trained model. So, what we do is that, so this is just pure Python script right now. We haven't merged it with the FastAPI yet. So we just paste everything that we need here to train our model. So get all the model, all the things we need from scikit-learn, and then also, use pandas to read the data and clean it up a little bit, very standard. And then put that, into a pipeline, and then, put in data, fit it, and transform, and it will do some transformation of the data, and then it will you can fit it into the nearest neighbor model. So this is the scikit-learn part. This is okay, this is how we train a model in a Python script. So let's merge it with FastAPI. So when we call predict in FastAPI, we probably want to take the trained model, which is the model has been fitted here, CRF, and then we want to call predict on it, right? And then, but we need the parameter from the user. So remember the name, the username is John Doe, that example. So instead of having the username, we'll have some parameters here, which we need the user to provide the length of the bill and length of the flapper here. So it's the measurement of the penguin. So after that, we can use that from the user's request. So that's the beauty of Fast API, because instead of you have to figure it out, okay, so what's the format and like how, if a user sends you a request, how do you get the parameters? You can just very easily define it just like that on Fast API. So you can just do that and use it directly. So you just call predict on it, because you can just easily grab this from the parameter and put it there. So yeah, maybe give it a try and see if it works for you. And if you encounter anything weird, please let me know, because then we can look at it together.
Adelie. Its result is Adelie.
Yes, so you get the result, right?
Yeah, it predicts Adelie.
Well, you can try different parameters, and also you can try it out with your Jupyter Notebook to see if it's what you expect as well. And if you're really fast, you already finished exercise 2, you can even try another model, right? Like there's so many models from scikit-learn. We're just using like k nearest neighbor. Maybe you can change it to something else to do the prediction, and and deploy it.
What is the difference between get and post? Like if you put post in predict?
Yes, we'll get to post later. So in API call, so get is so it's a different protocol. Again, like I won't go into the nuance, but for some of the functionality, it's only available in post. It's not available in get. So usually post is used to send more data. So get, like for example, this predict, right? I'm just sending like 2 parameters, which is very simple. But what if I want to give a data set to retrain the model? Then get won't be enough to transfer the data. So then you have to use post. So again, like I won't go into all the detail of why is get, why is post, but just think of like usually get is like, you just give some very simple parameters, usually like a query or something like that, and then you get a result back. So the main point of get is to get something out from the server. Post is more like I'm sending something to the server so the server can do something. Does it make sense? Okay. All good with exercise 2? Yes. If you don't look at me, I'll just assume that you're still working on exercise 2. Give me a thumbs up if you have good smooth thumb. Yes, some of you do, okay. So the next, exercise 3 is quite straightforward. It's kind of like add on to exercise 2, that what if, there's always some user who like breaking the rules, right? They'll be like, you're expecting me to put in a number. What if I give you something else, right? If you a non-number, or if you expect an integer, I give you a decimal point, and ha ha ha, will you be able to handle it? So to make your application, now it's become an application, right? It's just not just a machine learning model, because you have some API endpoint. So to make your application more robust, you may want to do some validation, right? So if someone gives you a bad parameter, you can say like, this is a bad request, that's why it doesn't work, this is why it doesn't work, you should fix it. So, it's kind of like a good error message, right? Like, it's like, if you have some code, you can't just let it, blow up and, oh, it doesn't work, or you better check if the input is correct, and then if it's not, then you can prompt the user, hey, this is what mistake you made, you better fix it. So, again, like Fast API is really good because it used together, like, it's used something that's provided by Pydantic. Anybody know Pydantic? Yes, we all know and love Pydantic because Pydantic help us to handle data validation very easily. So, and it's also because since like Fast API is using it, so we can also do that very simply in Fast API. So, if we do some typing in the when we taking the as the parameter, right, the bill and the flipper, we can define it to be a float. It needs to be a float. So if it's something that someone put in like A, B, C, D, E, then it's not a number. Then then it won't pass through the validation. So so that's the thing that we can do. But also we can do so. So that's the first step you can do, but also sometimes you want to check, like, for example, if you're just checking the type of the input, it doesn't do something like, oh, for example, it can't be negative number because, you're measuring a penguin, it can't be negative, this is breaking physics, so, so you have to do an extra check. You can also do that with the annotated in Fast API or Pydantic. It comes with lots of way that you could do some extra check on the data as well. So, for example, here I want it to be greater than 0, so you can use this as a extra check to check your data. It's not just a float, but it needs to be a float that's greater than 0. Now I'll invite you to not just try this out yourself. Have a read of the documentation because we just do one type of checking, right? Just check if it's greater than 0. But you may want to perform other checking, or you may want to do something else, like, for example, if someone, for example, the extra challenge, right? Like, what if someone put in the centimeter or millimeter, they want to be really specific, so will you be able to parse it? Well, I mean, it's quite straightforward, but you have to write some extra code to parse it. How do you do that, right? So this is, again, like, extra challenges for you to use your brain, try to solve this problem, and then documentation is your best friend. Read it, see if you can find something useful there to do it. Cool, let you do it. Anybody have finished the extra challenge? Let me know if you have done the extra challenge and show us how you do it. Okay. Who has a solution for the extra challenge? Love to see it. You still doing exercise too? Still thinking about it?
But if you put MM, you need to put just a number, right? It
Yeah.
doesn't accept.
So, how would you let that work as well? That's the challenge.
Oh, okay.
Okay, how's everybody doing? Anybody want to provide a solution for the extra challenge? Yes, no. If no, we better move on because I don't want you to miss your lunch or have lunch late. So I know it's very important, right? Like the food here is so good. So okay, we'll move on. But again, like last chance if you want to show your extra challenge solution, it's your time. You don't have to like show me the code. You can just tell me like, oh, is there a way to do it or like this? I think you can do it by doing that. No? Okay.
Can you do it by checking both for a string and like inside the function that you're calling? You check if it's a float or a string, and if it's a string, it ends with millimeters. You accept it.
Yeah, I think that's one way to do it because remember we can use a union to accept both type, or you can just accept a string and then do a parsing afterward. But then you have to also manually like if someone put in a nonsense, which is not 122 millimeter or like something with a unit, or they put in some gibberish, then you have to manually return an error message for that as a response. Yeah. Okay. Good. So let's move on to part 2, which is so part 1 we are only we assume that the model is like, okay, I've trained it, it's done, and then I just make it work, and then I don't need an endpoint to retrain the model. So of course you can if you have access to the server all the time, you can do the retraining in the background. You do it, and then you just manually update it. You can do that, but that may not be the most efficient way because someone else may want to provide the data and retrain the model. So, or you want to systematically collect the data and then you just like retrain the model without you manually intervening the server. So what we can do is to set up some extra function in your application to do that. So then first of all, we need to ask the question, right? Like, when do we train the model? There are different, according to your use case, you may have different time you want to retrain the model. You may be like, if someone, let's say, just manually trigger it, upload a new data set, and then like, okay, retrain the model with these new data. You manually trigger it with an endpoint. You can do that, or someone, your teammate can do that, or you can schedule a retraining at a certain time, but you may have to have another functionality in your application to collect new data. But let's put it aside. Let's look at this new model first, because the papers are cute, but let's try something differently. We have seen, we know that we can use Fast API to deploy scikit-learn model. What if I have a Keras, a Keras like and this data like classification model? So very different thing. We're using Keras. Also, it's like an image, image kind of deep learning thing, CNN. So okay, let's do it. So luckily, in the Keras documentation, there's already an example. So we just since we are not learning how to use Keras, we're learning how to use Fast API to deploy a model. We just took it, and then again, this could be your model. It's just that this time we just copied this one. Right. So so integrate this code in your Ring.py, and after that, of course, we can also do what we did before, but the problem is this Keras model takes quite a while to train, right? So if you notice this model.fit is taking longer than it was with scikit-learn. So because it's more complicated, there's more parameters, and So yeah, if you are using quite a bigger model that takes some time to train, of course, you can pre-train it, and then again, like pre-train and then deploy a pre-trained model, you can do that, but what if I want to train it when I start the application, right? Because, there may be new data that, every time you start the server, then it would just, retrain it, just make sure it's up to date. So, what you can do is to set a background task to do it. So, again, like Fast API is very good. It provides a lot of ways to do things. So one of the ways is to create a background task that is doing all these things in the background. So, right. So for the training, we put all the training things in a function. That's easier for us to manage when we integrate that in the application. So after that, so this is okay. Oh, I think I skipped ahead. Sorry. So yeah, like what if we want to like trick it manually with an endpoint? So the first exercise is that. So we want to train it. We want to trigger an endpoint to train it. So for example, whenever your colleague or you can schedule it, right? But let's forget about scheduling. Let's say like your colleague every day, first thing they do when they go to the office is to trigger this endpoint, the train endpoint, and to train the model. The problem is if you don't use a background task, so what happens is that the server is busy training the model. It won't do anything else until the training is done. So while someone is trying to train the model, the server is basically just stuck and nobody can use it anymore, even though like, oh, is it okay? Like, I don't need the new model. I just want it to still working while the new model is being trained. So what we can do is to use a background task to whenever someone triggers their training, it will run in the background, and while the other endpoint is still available, so it won't get it's for someone who is like a user, right? It looks like the server is down if you don't do it that way. They'll be like, oh, there's nothing happening. Why my request doesn't get a response? But if you do a background task, then you can still give a response to the user. You can either give them use the previous model to give them a result, or you can just tell the user, hey, the new model is coming soon. Just hold on a second, or try it again in like an hour or so. So so the least thing you want to do is for the server to hang there and not giving a response. So that's why the background task is very, very, very useful here. And so the first exercise in part 2 is to create a training endpoint and put it as a background task so that it will work. And also while it's training, the other endpoint will still be working. Or you can just try it, like if you want to try what I just said, you can try it without a background task and just put the training thing here, and you will see what I mean. Is it will just get stuck and the server will just be training and not do anything else if you don't use the background task. So yeah, give it a try.
To clarify, if it's not a background task, does it get stuck on that one single request, or does it start refusing any other requests at the time?
Yeah, so basically what it do is that it won't do anything. So what it does is that while it's training, any input will come after the training is done. So for a user, why I didn't get a response? Usually I get it immediately, right? So this time I didn't get anything, so they would think it's stuck. But then of course, if the training is finished and now the user gets a response, but in real life situation, maybe someone already gave up or the connection is already broken, and so it's the least thing you want to do if you design a server. So yeah, that's why you need the background task.
It's only 15 epochs.
Yeah, so that's what the example that I copy from is doing. So of course you can change it. You can deploy another model because this is just an example. Again, you can use something else. You can even do a transformer and use anything on Hugging Face. But this is just an example.
So even if you go out, even if you go out of that endpoint, the train endpoint, if you start it, it keeps running, or it stops if you go to another endpoint.
Yeah, so for the background task is basically enable async. So what happened is that other endpoint will still be available while the training is running. But of course you have to be careful, not to interfere with the training because that may create another problem. But so for example, if you have another endpoint that do nothing with the training, then it will still work if you put it as the background task. Okay. How's everybody doing? Good-ish. Right. Maybe 3 more minutes, then we'll move on. Okay, so good to go? Yes. Okay, so yeah, now we have see how the training work, but there's no prediction here yet, right? We only have info. We can see what's is going on. We have the training going on, like your colleague can start training, but nobody can get the prediction, which is weird. So we can now add the predict endpoint here, and yeah, like because we when the user want to predict something, of course they need to provide an image, right? Because this one is then image recognition to see like what number you're providing. So now we need to use the post endpoint. So go back to the point, right? Like when do we use a get endpoint? When do we use a post endpoint? So this time the predict, even though it's a predict, we use a post endpoint because get only allow us to transfer very simple information. For an image, it's quite a complex data there. It's not just a few characters. It's it's a lot of bytes or whatever. So we need to use a post endpoint to be able to upload an image for the endpoint to use to do some prediction. So so right now that's why we have to use something different, and also for Fast API we use upload file. This is provided by Fast API to handle this kind of situation, which is again very good. That's why we use Fast API, and of course image processing we can use Pillow. I just assume everybody is familiar with Pillow if you have done a little bit of image processing before. So yeah, so we can do that. While you are trying this, you may encounter some things, or spoiler, you may encounter an issue that when you start the server, the training is not done yet, right? So I don't have a model. Can I predict something without a model? No. So that's why after that, that part in the second part here, you will see that we use a lifespan event, which means that we would trigger the training when we start the application, and nothing can be done until the first training of the model is done. So there's a model available, and afterwards the model will be clear because you may want to clean up something that you're not using, and then every time you want to refresh, you want to train a fresh model to start the server. So you can do it with that lifespan event. So you can see that this is that there's using U here, which is makes this a generator. I think I used the term correctly. And also like it's async because it's an async context manager. So don't worry too much about those. Just use it as like, oh, this is how you do it. Like it's kind of like a format that you would use this decorator. It will be an async generator. There will be a U. So anything before U will be happening when you start the server and before any endpoints available, and then anything after you is that when you shut down your server. So that's like what you will do right before your server gets shut down. So usually there's some cleanup things that's going on. Yeah, so that's what it is. Give it a try and see if you find anything weird. I love seeing weird things. So let me know. Yes.
How do we send the post request to upload the image? Like with the command.
Right. So I would suggest if you want to test that out, you go to the documentation UI. That should give you a button to upload the image. Yeah. And of course, when when the user, the endpoint client need to also implement that upload button in the UI as well. But I think for testing, we already have a very good documentation UI you can use to test it out. to move on? All good? Okay, I'll give you a couple more minutes. Okay, let's move on because again, we don't want to be late for lunch. So, yeah, there's the risk there. But anyway, so as you see that now we can upload a file, right? Because we have tried that at the project endpoint, we upload a file. What if I'm not just uploading one image, I'm uploading a zip file full of images that I can retrain this Keras model, right? So, yeah, we are trying to do that now. And of course, we need to do some modification of training because this time we are not just using the data set that's already in there, but we are trying to also take in the training data from outside as well. So this is the modification we need to make. Yeah, mainly, like I said before, the data now is loading from outside. And if I don't provide the training data, then I can just read the data set that is already in there. But if the training data is provided, for example, the user uploaded, then we just use that to refine the model. So that's the modification that we have here. And also, we are now not just saving one model, we are saving multiple models. So because when we are retraining the model, there is a chance that something goes wrong and we want to go back to the previous one. So that's why we are storing multiple models there this time. So right. Again, we need to have post endpoint this time again because we are uploading file. Uploading file is there's lots of data being handed over to the server, so we need to use the post endpoint to do that. And this time we would be accepting a zip file, and also let's see. Yeah, we will have zip file, and also there should be the target inside as well. So yeah, everything should be packaged properly, assuming the user read the menu and know how to, give this zip file, and it should work. Fingers crossed. Yeah, of course we can try it with the documentation, but then sorry, I made a mistake. Okay, so all the training data is in the zip file, but we are not uploading the zip file. We are uploading all the images one by one. Not one by one manually, but technically one by one. And then also the target is actually in the file name. So that's the design of this. I think I've tried, the zip, handling the zip file before as well, but I ended up using this design instead because I want to try something else. So yeah, we are uploading multiple files this time, and it's challenging. So that's why we are not using interactive documentation like we did before, because before we only upload one image, and I can just click one button and upload one image. Now, if you want to upload multiple images using the documentation is not like designed for you to do this. So you have to upload them like clicking it. Let's say you upload 10 images, you have to click the upload button 10 times, which is annoying. So I have built a extra interface for you to upload. So again, like this is showing another thing that you can do with Fast API is to create an HTML page with Fast API. So if you see here the content inside this string here, this actually is a very simple HTML file in plain text format. So this is, there isn't any like clever design here. It's just that we have a button. We can just upload multiple files with that button. So that's why we have this here. Again, if you have someone who loves designing like web pages and want to make it pretty, you can make it pretty. But again, this works, and I don't care if it's pretty or not. So so this is the new upload endpoint we have here, which is an upload HTML endpoint, but this one is not actually the train endpoint. So the train endpoint is still taking multiple files. So in case someone doesn't want to use this HTML, so your colleague makes something more pretty, more user-friendly, more accessible, then they can just directly call the train endpoint, provided that they can provide the uploaded sequence of image. But since we don't want to click that button 10 times, so let's use this makeshift upload endpoint that I created here. Does it make sense? Okay. Yeah, I know it's like complicated, but yeah, it works. Trust me. Okay, so after that, this is basically almost towards the end. So again, give it a try. If you are very good with HTML and CSS, you can make it pretty if you want to. But again, just try it out, see if it works, and then do the extra challenge if you have time, and to see if you can do that as well. So. Okay, so we have around 10 minutes for lunch, and unfortunately, I don't think I will have time to cover the Docker bit, but the Docker part should be quite straightforward. It's just that if you are familiar with Docker, I don't think you will have any issues with that, but you know, it's just, you know, introducing a new tool if you haven't used it before, that you know, you can pack everything in a container. And why it's good, because, you know, it works on everybody's computer, not just yours computer. So and usually that's the tool that we use if we want to deploy something. But if you have questions, since I'll be here until Friday, you can come and ask me at any time. And also, if you want to say like, oh, can I use it with Transformer, which, you know, I recently tried it out as well. So if you want to like see how you can use Fast API with Transformer and Pipeline from Hugging Face, you can come to talk to me again. Until Friday, you can find me at any time. You can also book a one-to-one with me on Thursday if you want. It's, you know, on my social media, you know, or come get a sticker from me, then you will have the link to do that. Anyway, so let's go through the race condition part before we go for lunch. And then, again, like, you know, you have a chance to ask me questions anytime and try it out at home, and not at home, but, you know, after today, and then, you know, talk to me before Friday. So, race condition. What is race condition? So, like I said before, if someone trigger a training and the model is being trained, right? So we don't want to interfere with it because something weird may happen, and we may not want that. And so, for example, I think I have made an example here that what if two person is trying to, you know, train the model at the same time, right? So at the end, which model will be the one that get to be used? So there are things that, especially when you are doing some async or concurrency programming, this is something you have to put extra attention to and to be careful, because if you are sharing some information, so for example in this case we're sharing the model, right? And if you are trying to modify the model at the same time, for example by training it, then something unexpected may happen. You know, the best case scenario, something break and then you figure it out, oh, and then you fix it. Worst case scenario is you don't know, it's kind of work, but then something weird happened, you don't know why, because the race condition is happening, you know, hidden. So, what can we do to combat this problem, this issue? In this workshop, of course, there's lots of ways you can do it. For example, if the training is going on, maybe you block the endpoint, like nobody can touch the model until the training is finished, or like if, you know, nobody can retrain the model until the training is finished. You can still predict, but you can't, you know, retrain the model until this training is finished. You can do that, but what we are doing here is another way. So again, like this is just one way of fixing it, but there's also other way to do it. I would give it as a thought exercise, so you can like think about, okay, so what's the other way that I can do that to avoid race condition? But the example here, what we do is to save the model in disk. So we'll save that in hard drive. Again, there's an advantage for that. Because, for example, if you want to roll back, if you want to really like, you know, something went wrong or you want to investigate, you have all the record, you can dive into the disk and then, you know, access the model and see what's wrong. But again, like if you don't have a disk available for that server, or you don't want to save all the, you know, model because they are big and cost a lot of money to store them, then maybe you have to think of something else. Anyway, we're just using a very simple NS, you know, Keras model, so that's fine. You just save the model, and then by doing it, we change a little bit of the design of the model. So, for example, when we train the model, then it needs to be loaded from the last one that is available, and also, like when you do some prediction, which model to use the latest one, even though maybe some new one is training in the background, I'll just use the last one that got saved. So no race condition, nothing's crashing. It's just that it may be a little bit out of date, but it could still be fine. So that's how we fix it in this case. But again, like, you know, you can do the extra challenge. You can think of other ways to do things, and you know, also, you know, for saving a model in disk, there's another advantage is that you don't have to, you know, train the model every time. You just load the latest one when you start up the server again. So yeah, that's another advantage. Everything that's, you know, good things, advantage and some disadvantage, and then you have to really think what's best for you. So give this a try, and again, I will leave the thought exercise to you. If you have a brilliant idea, let me know, because, you know, I may add it into the workshop and maybe give you honorable mention as well. But yeah, I hope you enjoy the workshop, and yeah, again, I'll be here until Friday, so talk to me at any time if you have any questions. If you want a sticker from me, come to me, and I have stickers. So, yeah. My sticker is very nice. And you can book a time to have a one-to-one to me on Thursday if you want.
Have you tried Tornado?
Huh?
Tornado?
Tornado? It's I haven't used it personally, and of course people talk about this, you know, other web framework that lets you build something similar like Django, Flask, and Tornado that you mentioned. I haven't used Tornado personally. I found Fast API to be the best for this because it's very easy to use, it's very modern, it's very popular and well maintained, and you know. But again, like if you think that Fast API doesn't suit your use case, and others are better. Like for example, if you want something that like come with a CMS, and then like, you know, it just handle the data and very give admin access to someone who is not a coder, then maybe Django is better. So again, depends on the use case.
Because I'm using Supabase, and it seems it doesn't, it's not working too fast, you know. It seems, but maybe it's my code is not efficient. But yeah, it doesn't seem to work very fast with Supabase. I mean, it's kind of fast, but yeah, maybe my queries they're not doing it the right way. I can improve my queries, but yeah, they seem that it's taking a long time.
I think the first thing is to figure out what makes it slow, right? What is the choke point? So after looking at that, then you know whether it's the code that build the server is slow, or is it like, oh, you can, like, the model is very huge, you need to maybe use another way to like make the model faster.
You get everything active asynchronous, or how do you do?
Yeah.
Yeah.
Maybe there's some blocking somewhere. Who knows?
Yeah.
Yeah, like,
You need to profile the code and see that the problem that's blocking.